All right, 9.2, we're talking about angles and radian measures. So we're going to be drawing angles in standard positions. We always start at an initial side, which over here to the right, this is 0 degrees. This is where we start. This is our initial side to the right. Our terminal side is where we end. So this would be the angle that we're talking about from 0 to here. So we go up and in counterclockwise position when we are talking about positive angles. And then we go down and clockwise when we're talking about negative angles. So we just go in the opposite direction when we have negatives.
So would they come out in the middle of the vertex?
Yeah, it depends on like what our angle measure is. So like if we had something like negative 50 degrees, it would be like here. So we just go 50 degrees, but in the negative direction. How many degrees is a full circle? 360. So 0 and 360 are talking about that same line because that would be our full circle there. And then we have 4 quadrants. So what's 360 divided by 4? 90. So each quadrant is 90 degrees. So from 0 to 90 is our first quadrant. We can call this quadrant 1. From 90 to 180 would be our second quadrant, quadrant 2. 180 to 270 would be our third quadrant. And 270 to 360 is quadrant 4. So we start at 0. First quadrant we go into is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So in example 1, we're going to be drawing angles in standard position. So we're going to start with our little chart here. We have 0 degrees, 90, 180, 270. And we want to go 240 degrees. So in between which 2 degrees that we have up there are we looking at?
180, 270.
In between 180 and 270. Do you think it's closer to 180 or closer to 270? A little bit closer to 270. So we're going to be about there. So this would be 240 degrees. What quadrant is this in? Quadrant 3. Awesome. So you could draw your little like that. It doesn't matter how far apart. You're just showing like this is the angle. That would be 240 degrees. If your line went here, that would be fine. That actually might be a little bit more precise, but somewhere around there-ish. All right, for B, we have 500 degrees. So we've got 0, 90, 180, 270, 360. So where would 500 be? So we would have to go all the way around and more. How much more are we going to have to go? How did you know that it was 140 degrees more? You subtracted 360 from it. Awesome. So we can subtract 360 to show that we just went around one time, but we need to see how much more we have. So if we do 500 minus 360, that would be 140. So we would want to go around another 140 degrees. So what quadrant would that put us in? Quadrant 2. And we'd be kind of in between 180 and 90, about there. Yeah, so if you go around more than once, it just kind of looks like a spiral. I would just say circle it around once and then see how much more you have to go. So let's do C. So 0, 90, 180, 270, 360. We go backwards. We go backwards meaning do we go up or down here? Down. So we're going down negative 50 degrees. So what quadrant do you think that's going to be in? Quadrant 4. We're only moving 50 degrees, but just in the negative direction. So we'd be about there.
So if you do it, would you subtract 50 from 360? Or mathematically? Like if it was a bigger number.
Yes, and we're going to talk about that in the next couple slides. Any questions here? Okay, on the next page, let's look at number 2. So we've got 0, 90, 180, 270, 360. So where would 300 degrees be? Quadrant 4. We go around. Is it going to be closer to 270 or 360? A little bit closer to 270, so about there-ish. But it's going to be in quadrant 4. All right, let's do number 4. So I've got 0, 90, 180, 270, 360. We have negative 450 degrees. So where would we go? We go down. We go down all the way around once. And how many more do we have to go? How do we find out? Do we subtract 360 here? We'd be adding 360. Just because it's negative, so we want to add 360 to find what the smaller angle would be. So that would give us negative 90. So we're going to go 90 degrees more, but continue in our negative direction. So if we go another 90 degrees, that's just one quadrant there. So we end up falling on that 270 degree line there. If you need to, for negative angles, you can always just label them backwards. So here this would be negative 90, negative 180, negative 270, negative 360. It's just like going in the opposite direction. So if it falls on one of the axes, then it's not in a quadrant. So it says in example 1b, the angles 500 and 140 are coterminal angles because their terminal angles coincide. So we said that for 500 degrees, we went all the way around once and 140 degrees more. So it ended there. If I had something like 140 degrees, I would just go from 0 to 140 degrees. And that ends up being the same terminal spot. It's almost like it's the same angle. So we call these coterminal angles when they have the same terminal position. That ending arrow is the same thing. It's technically not the same degrees because we have 500 and 140, but it's, yeah. But it's like the same position.
So like when you subtract 360 from 500, you're going to get 140.
So we can find coterminal angles by either adding or subtracting multiples of 360. So it's essentially what we just did in the last couple examples where we had to add or subtract 360. But this is just asking us for coterminal angles. We don't have to graph them. But they would have the same ending point on the graph. So let's find a positive and negative coterminal angle for negative 45. So let's start with the positive one. What would I need to do to find a positive coterminal angle here? Add 360. So what's negative 45 plus 360? 315. 315 what? Degrees. Don't forget that little degrees symbol. Now we need a negative coterminal angle. How do I find a negative one? Subtract 360. So I have negative 45 minus 360. So that gives us negative 405. Negative 405 what? Degrees.
So when it's like that, like how it's put in the sentence, it's like two separate ones?
Yeah, so it's like a part A and a part B for each question. You just have to find the positive and a negative. Let's look at B. So we want to find a positive coterminal angle first. What would I need to do to find a positive one? We can add 360. So what's 395 plus 360? 755 what? Degrees. Well, let's see. What would I need to subtract from 395? Let's subtract 360. What do we get? 35 degrees. 35 degrees is still positive. So would that count for my negative coterminal angle? No, but that would actually be another positive coterminal angle. If you answered this question on a quiz and said 35, that would be right. If you answered it and said 755, that would be right. So they both work as positive coterminal angles, but if you said 35 for the negative one, that would be wrong because is 35 negative? No. So what would I have to do? Subtract another 360. Or if you saw from the beginning that this is greater than 360, you could subtract 720 from it. So just like 360 twice. So subtract another 360. What do we got? Negative 325 degrees. All right, let's take a look at number 7. So I want a positive coterminal angle. No, you don't have to graph. How would I find a positive coterminal angle? Add 360. What do I get when I add 360? 1,100. 1,100 what? Degrees. How would I find a negative coterminal angle? Subtract 360. 740 minus 360 is 380. Is that a positive or a negative coterminal angle? No, remember we're looking for a negative number. But this is actually a positive coterminal angle. So we can add 380 to our list of positive ones. So if you said 380 as a positive coterminal angle, that would be right. You don't have to continue to list them. Just give me one of each. But just make sure one of them's positive, one of them's negative. What would I have to do next? So we got 20. Is 20 a negative coterminal angle? No, it's actually still positive. So we could add it to our list of positive ones. What would I have to do again? Subtract 360. So we get negative 340. Now we have a negative 1. So that would be our negative coterminal angle. So let's find a positive coterminal angle. What would I need to do to find a positive one? Add 360. What's negative 135 plus 360? 225 what? Degrees. And we also need a negative 1. How do I find a negative coterminal angle? Subtract 360. So negative 135 minus 360. Negative 495. 495 what? Degrees. Next, we're going to talk about radian measures. So radian is the measure of an angle. So we can measure angles in radians or in degrees. It's just another unit of measure. So radians and degrees relate to each other. 360 degrees is 2 pi radians, which if we cut both of those in half, that means 180 degrees would be pi radians. So we can convert from radians to degrees and from degrees to radians. So going from degrees to radians, we would multiply by pi over 180. So we take whatever degree measure that we're given and we multiply it by pi over 180. We can also go from radians to degrees by multiplying by 180 over pi. So you just have to know the difference between the two. All right, so we're converting the degree measure to radians or the radian to degrees. So in A, is this degree or radians? Degree. So if I'm going from degree to radians, what do I have to multiply by? I multiply by pi over 180. And we can multiply these two together. We get 120 pi over 180, but we want to simplify our fraction as much as possible. So just by looking at it right off the bat, what number goes into both 120 and 180? 20 does for sure. I would just say let's cross off the zeros just to get rid of them. And then let's see what number goes into both 12 and 18. 6. So we can divide them both by 6. So we are left with 2 pi over 3. So this would be our radian measures. For radians, you don't have to write radians. Just by not putting degrees, it's implied that it is a radian. So
the radians in like the formulas is basically telling us not to put degrees.
Mhm. Just leave it with pi in your answer. All right, for B, what is this one? Is this pi? Is this radians or degrees? Radians. So how would I convert it to degrees? Multiply it by 180 over pi. So we can multiply straight across, but I would say before you multiply, just get things to cancel. Simplify a little bit. You can only cancel out if something's on the top and on the bottom. So anything in common on the top and the bottom? The pi's, so we can get rid of those. What about 12 and 180? What goes into both of those? 6. So 180 divided by 6 would be 30, and 12 divided by 6 is 2. So I'm left with negative 30 over 2. Can this be simplified more? To what? Negative 15 what? Degrees. We're talking about degrees here, so don't forget your degrees symbol. My math teacher in high school used to write chickens, ? Yeah, like if you didn't put the degrees, be like, what are you talking about, chickens? All right, on the next page, it just talks about degrees and radians of special angles. So we know, like yesterday, we did 30, 60, 90 triangles. So 30 and 60 are special angles. It just kind of converts them there for us. You don't have to memorize this. Just make sure you know how to convert. So just know how to multiply. So let's do a few more. Let's do number 9. So number 9 has degrees. How would I convert this to radians? Multiply by pi over 180. So before you multiply, let's simplify. What goes into both 135 and 180? 5. Let's divide them by 5. So 5 goes into, let's write it down. 135. 5 goes into 13 2 times. So 27. And 5 goes into 180. 5 goes into 18 3 times. 36. So I have 27 pi over 36. Can I divide 27 and 36 by anything? 9. 3 would work, but then you'd have to simplify it more. So let's do 9. So we get 3 pi over 4. Awesome. Now we can't simplify anymore. Let's try number 10. So let's convert to radians. What do we have to multiply by? Pi over 180. So I can cross off the zeros. What goes into both 4 and 18? 2. So that would be 2 pi over 9. Negative 2 pi over 9. Do I need a degree symbol here? No, because we're talking about radians. For 11, what would I multiply by? 180 over pi. So the pi's cancel. You don't have to multiply 5 times 180. Just simplify it before you multiply. Does 4 go into 180? How many times? 4 goes in 180 4 times. 45 times. So I have 5 times 45 left on the top and nothing on the bottom. So I have to multiply 5 times 45. So if you can't just do that in your head, write it down. I know you guys know how to multiply this. We learned it in the 3rd grade. So 5 times 5 would be 25. 5 times 4 would be 20 plus 2. Awesome. 225 what? Chickens. Degrees. Is 12 in degrees or radians? Radians. Because it doesn't have a degree symbol. It looks a little different because it doesn't have a pi in it, but it is in radians. So what would I do to change it to degrees? Multiply by 180 over pi. So this one would be an example where you can use a calculator. If I gave you something like this on the test, you could use a calculator. So I would multiply negative 6.28 times 180. Is this in degrees or radians? Degrees. So don't forget a degree symbol.